Hello children, welcome back to GradeBooster. Our today's lesson is magnetic effects of electric current. So we have seen electricity. Now in this lesson, we are going to see how the electric current is affected by the magnetism. So that is the magnetic effects of electric current. So we already learnt about magnetism in lower classes. So what are magnets, different type of magnets and magnetic fields. Let us see once again the basic concepts of magnetism. Here is a bar magnet. So a magnet will have some magnetic strength around it. So this area till which the magnetic strength is extended around a magnet is called as magnetic field. Okay? The region around a magnet, this is a bar magnet, the region around a magnet where magnetic force is felt. The magnetic force is felt, that is called as magnetic field. We represent this magnetic field with field lines. These are the magnetic field lines. So the magnetic field lines, they begin at the north pole and they go to south pole. This is the arrow mark you can see. They start at north pole and end at south pole. So the magnetic field is represented using magnetic field lines. These are the magnetic field lines. So the magnetic field lines, they start from north pole and end at the south pole. They start at north pole and end at the south pole. And these lines, they never intersect. See, none of these magnetic field lines are intersecting. They do not intersect. And we can observe one more point. At some places, the magnetic field lines are very close. See here. Here the magnetic field lines are very close. Here they are very close. Here they are very close. Here they are very far. So where the magnetic field lines are very close, there will be more magnetic strength. So the magnetic force is more at these points where the magnetic field lines are very close. So at these points where the magnetic field lines are far, there the strength of the magnet is less, the magnetic force is less. So magnetic field due to a current carrying conductor. Next, so this is all about the basic concept of magnetism, that is the magnet and magnetic field. Now let us see the relation between current and magnet. Magnetic field due to a current carrying conductor. What is current carrying conductor? Any metal, any wire carrying conductor is called current carrying conductor. There is a copper wire, it is conducting electricity. It is called as current carrying conductor. So a current carrying conductor, it produces a magnetic field around it, right? So that is the relation between magnetism and electricity. Repeat. Next, straight conductor. So I told you that if there is a conductor, when electricity is passed through a conductor, around the conductor a magnetic field is produced. Now let us see the conductors of different shapes: straight conductor, a looped conductor and a coil. So how the magnetic field is produced when the conductor is in different shapes? First, let us begin with the straight conductor. Here is a straight conductor, straight. So this is the conductor. Now the electricity is being passed, the direction of the current is bottom to top like this, it is going like this. So when the current is going like this, okay, when the current is going like this, so the direction of the magnetic field is like how I am folding my fingers, in this way, in this way, in this way. So in this direction there will be a magnetic field. So this is called as right hand thumb rule. Okay, right. So field lines are concentric circles around the wire. These are the magnetic field lines. How they are? They are like circles, concentric circles. So the strength increases, the magnetic strength increases when current increases. If you increase current in the conductor, then the strength of the magnet increases, magnetism increases. Okay. So, if you are going far from the conductor, the magnetic strength decreases. If you come close to the conductor, the magnetic strength increases, right? So, here this is the magnetic field around a straight conductor. Okay. So, for a straight conductor, if the direction of the current is bottom to top like this, what will be the direction of magnetic field? Like this. How you fold your fingers, that is the direction of magnetic field, right? So, this is about the straight current carrying conductor. Now, let us see a loop. This is not a straight conductor. Now, this is in the form of a loop like this. Circular coil carrying conductor. Circular loop. Now, here the field lines form concentric circles near the wire. Here, see the concentric circles, how they are formed. Here also concentric circles are formed. But here you see this red color arrow mark shows the direction of current. So, now the current is passing in this direction. We use right hand thumb rule. So, what is the direction of the magnetic field like this? You can see the arrow marks coming like this. This is the direction of the magnetic field. The same current it is passing through the circular coil, and from here it is coming down from top to bottom. Here bottom to top, from here top to bottom. Now, you have to see like this, down. So, this is the direction of the current, this side. Now, what is the direction of the magnetic field? That side. You can see the arrow marks. Okay. So, at the center the magnetic field lines will be almost straight. So, the magnetic field increases when current increases, number of turns increases. So, if you are taking a coil, number of turns, this is not okay, this is a single wire, okay, or a metal conductor. If you have taken a coil like this, that means number of turns. If you increase the number of turns in a coil, then the strength of the magnetic field increases, right? So, the magnetic field increases when current increases and number of turns increase, right? This is circular loop. So, in this circular loop, you can take one wire or a wire with so many coils, so many turns you can take. Next, solenoid. What is a solenoid? A solenoid means a coil of many turns of insulated wire. This is solenoid. This is an insulated wire which is having so many turns and arranged like this. This is called as a solenoid. So, its solenoid produces uniform magnetic field. This solenoid, it produces uniform magnetic field just like a bar magnet. Just imagine a bar magnet, just like a bar magnet. It is also producing two magnetic poles, south pole, north pole. Now, you can see there are some straight magnetic field lines inside, just like how they will be in a bar magnet. In the same way, in the solenoid also straight magnetic field lines are seen here. Okay. So, when the current is passed, here this is the negative terminal, positive terminal, it creates a magnetic field similar to a bar magnet. Okay. So, it produces uniform magnetic field. Ends act as north and south poles. The ends of the solenoid act as north and south poles. Now, we can use this solenoid to make some electromagnet. If you place any item here in between these, okay. So, any magnetic material, if you keep that there, any soft iron or something that can be magnetized. If you keep the soft iron, it can magnetize it by placing it here. So, when you place the soft iron in between this coil, in between this space of this solenoid, you can make it into a magnet, right. So, we can make an electromagnet by placing a metal, you can make it into an electromagnet by using this solenoid, right. Next, we see force on a current carrying conductor in a magnetic field. So, now we studied the relation between magnetism and electricity. Now, one more thing is coming into that is force, right. Let us see. Force on a current carrying conductor. There is a current carrying conductor. So, this is the current carrying conductor. Current is going like this. Okay. So, when there is a current carrying conductor like this, and here is, this is the direction of the magnetic field. If this is the direction of the current flow, this is the direction of the magnetic field. So we studied this relation between magnetism and current. When this is happening, some kind of force is exerted. There is a thrust or motion in this direction. There is a thrust or motion in this direction. Okay. So a conductor carrying current experiences force in a magnetic field. A conductor carrying current. A conductor carrying current, it produces a magnetic field. So this magnetic field, when a conductor is carrying current, it experiences, that conductor will experience a force because of that magnetic field. So the direction depends on the current and field of direction. The direction of the motion depends upon the current and magnetic field. This is Fleming's left hand rule. This is the left hand rule. So what is this? This is the direction of the current, and this is the direction of the magnetic field, and this is the direction of the thrust or motion. Okay. So the force acting on that. The thumb shows the force acting, the direction of the force. The first finger shows the magnetic field. The second finger shows the direction of current. Next. So electric motor. Electric motor. So what is electric motor? In fans we use electric motor. When we give electric connection, the fan will rotate. That means the electric energy is converted into some motion, some mechanical energy. How is this happening? Just now we discussed in the previous slide. When the current is passing in a conductor, that means in a coil or in a wire, magnetic field is produced. Yes? So due to this magnetic field, the conductor, it experiences some force. This force makes it move. It causes movement, rotation. Right? So let us see. On basing this principle, electric motor is constructed. So electric motor is a device that converts electrical energy into mechanical energy. Here is the simple demonstration of electric motor. Here magnetic poles are there, south pole, north pole, magnets are there. It is called stator. Stator means which is fixed. It won't move, it is fixed. At the center the coil is there. This is called as armature, coil is there. So for this coil, using a commutator, we are giving power source. We are sending power into this coil. Now you see the direction of the power. Here the current, it goes like this in this direction, and it comes like this, and it comes down in this direction, and again it will come back to the circuit. So the green color lines here are showing the direction of the current, and the red color lines are showing the magnetic force, north pole to south pole, magnetic field, direction of the magnetic field. This is the direction of the current. Where is the direction of the force? Yellow color line you see. This is the direction of the force. So when this is the direction of the force, this coil will move up like this, and here it will go down. So it will rotate like this. It keep on rotating. So when it keeps on rotating, it will rotate the axle, so the motor rotates. So in this way, electric energy is converted to mechanical energy in an electric motor. Okay. So based on the force on a current carrying conductor in a magnetic field. So this is a simple motor. What are the parts of it? Armature or coil, permanent magnets, these are the permanent magnets, split ring, this is called a split ring or commutator, and brushes, battery, this is the brush, and power source is the battery. These are the parts. Okay. So when the power is given, then this power, it goes like this, it creates a magnetic field, and this creates a force which moves the armature. Armature means the coil rotates, right? Next. Now, by using electricity, by sending electricity into a motor, we created mechanical energy. Can we do it in reverse? That means I am going to rotate something. Can I produce electricity? Is it possible in reverse? If electricity is given, mechanical energy has come. So by using mechanical energy, can we recreate the electrical energy? Yes. Electric motor uses electric energy, it converts to mechanical energy. There is one more device called as generator. Generator, it converts the mechanical energy into electric energy. So now let us see this reverse conversion, production of electricity. Production of electric current happens when magnetic field changes. When you are changing the magnetic field in the previous setup, then electricity can be produced. Now let us see, to understand that we need to learn about Faraday's observation. What did Faraday observe? Moving a magnet in or out of a coil. If you are moving a magnet in or out of a coil, it induces current, it produces current. If you are moving a magnet in or out of a coil, it produces current. So if there is no motion, no current is produced. These are the Faraday's observations. Now let us see Fleming's right hand rule. Right hand rule. What is this? So this is the direction of the current. This is the magnetic field. This is the direction of the motion. This is Fleming's right hand rule. This is the direction of the motion, current, magnetic field, and this is flow of current. Now, electric generator. I told you that electric generator converts the mechanical energy into electric energy. If there is no power, we use generator. What do? We put some kerosene, diesel or petrol into the generator. So when we put the fuel, the engine will rotate. It will rotate an axle like this. This is an axle. So this axle is connected to a coil. This axle is connected to a coil. So when a coil is rotated between magnets, electricity is produced. Electricity is generated. So we are calling it as generator, electric generator. So the coil rotates between magnets. It induces current. So here is the coil. The coil is connected to axle. Who is rotating the axle? The generator will put some fuel. That fuel will run an engine. That engine will rotate this axle. When the axle is rotated between the permanent magnets, when the axle is rotated, electricity is produced. So generators are of two types. AC electric generator which produces AC current, alternating current, and DC electric generator which produces DC, direct current. Okay. What is the difference? Slight differences are there. Here you can see two slip rings are there here. For the axle, two slip rings. Here only one slit ring, okay, split ring, the ring which is split, and here it is slip rings. Slip rings are there. The rest of the attachment is same. This is DC electric generator, this is AC electric generator. AC generator uses slip rings, produces alternating current. DC generator uses split ring, produces direct current. Okay. So next, what do we have? Domestic electric circuits. How the electrical wiring is done at our home. What kind of wires are used in connecting our fans and bulbs, lights, TV, washing machine and all. So the wiring in our house, inside our mains, we will have three color wires. Red color wire is the most important one, that is the live wire which carry the current. And this live wire carries the power and it supplies the power to components. And from the components, the power has to be taken back by the neutral wire. Neutral wire. That means, for example, here is a bulb. So for this bulb to work, the bulb should be connected to live wire, the other end of the bulb should be connected to neutral wire. Only then the bulb glows. In this way, in our house, the wiring is done. Then what is this green color wire? Why this extra wire, third wire, earth wire? This wire is used for safety. For example, if there is any high voltage in our circuit, in our wiring, so this high voltage may damage the components, electrical components, whatever the TV, AC, whatever we are using, this high voltage, it will damage the boards. So when there is a high voltage, that will be taken up by this earth wire, and this earth wire is connected to earthing in our house. So nearby our house, we will make a big pit with coal, salt and other materials, and we will keep a big copper conductor. So whatever the extra voltage is produced in the house, and that is collected by this earth wire and it is dumped into the ground. The high voltage is dumped into the ground. So that arrangement is done using earth wire. Right? So earth wire is used for safety purpose. For wiring purpose, live wire and neutral wire are needed. And there is one more safety precaution for our house to protect our electrical components from high voltages overloading. That is the fuse. Here you can see this is the fuse. This fuse is used in small components. This is used in our mains, electrical mains, from where the power comes from the main pole to our house. So there we will find this kind of fuse. The fuse is connected with some wire which is made up of an alloy, its melting point is less compared to copper. Usually in the wires copper is used, but here some other alloy is used which melts easily. So when there is high voltage, this fuse wire, it melts and it stops the circuit. It will not allow the high voltage to enter our house. So once the fuse is gone, we can understand that there is high voltage. Again we will keep the fuse wire to restore the current. So fuse wire is made up of metals that are having less melting point. When there is more heat due to high voltage, then the fuse melts and it stops the flow of current. Okay. So what are the components of our wiring? Live wire, neutral wire, earth wire. Fuse is a thin wire that melts when current is excessive. It prevents damage and fire. Okay. So fire happens because of the electricity. What are the two reasons for fire accidents due to electricity? One is short circuiting. Second one is overloading. See here, short circuiting. So when the live wire and neutral wire gets connected, so if there is any damage to the wires and if the insulation is gone, then the copper of the wires is exposed. If live wire and neutral wire are touching, when the copper inside copper is exposed, it leads to fire. Okay, it is called as short circuiting. It is called as short circuiting. Second thing is overloading. See, this is a small plug. For this small plugs box, they have connected so many plugs. Lot of current is drawn here. So it becomes hot, heated, and it produces fire. So too many appliances on one circuit, excessive current leads to overloading. So these two are kind of accidents or problems that are caused because of high voltage and overloading. So this is all about the magnetic effects of electric current. Hope you liked this video. This is a very quick revision, covered almost all the points in a summarized way. I hope you liked this video. If you like the video, please give it a like and write your comments, and please subscribe to GradeBooster channel. We'll meet again with another interesting video. Thank you.
Thanks for watching. Please like the video. Please share this video with your friends. Please subscribe to GradeBooster channel. Press the bell icon to get all the latest updates. Check the description to find links of other useful videos. Check the end screens for our new videos.